to play badminton. Do you want to join me?
It's okay, I'm fasting today. But later, I will have dinner with my friend. Do you want to join us?
Oh, sure. I will join you guys later. But can my friends join you too?
Of course, see you later.
Okay, bye Nani.
Guys, I have few questions to ask you guys.
What it is?
Why don't we faint or collapse when we do exercise like badminton or jogging, even after 20 to 30 minutes?
I think it is because our body is undergoing the process called glycolysis.
Glycolysis? What is glycolysis?
Basically, glycolysis is a metabolic pathway that breaks down glucose molecule into two molecules of pyruvate, which are releasing energy in the form of ATP and NADH.
This process is also a first stage of the aerobic and anaerobic respiration because it doesn't need oxygen.
Glycolysis is undergoing two processes, which are energy investment phase and energy payout phase.
Oh, I think I heard that before. Energy investment phase is a process that requires two ATP molecules to produce high energy intermediates, while energy payout phase is a process that metabolizes the intermediates to produce 4 ATP molecules and 2 NADH molecules.
Yes, it's true. During energy investment phase, glucose is phosphorylated by hexokinase to form glucose 6-phosphate G6P. But G6P cannot pass through the membrane, so this reaction requires a molecule of ATP. After that, G6P is converted into fructose 6-phosphate by glucose isomerase.
Plus, fructose 6-phosphate is phosphorylated into fructose 1,6-biphosphate by the enzyme called phosphofructokinase. Then the product creates an unstable molecule, so it consumes the second molecule of ATP. And then, the fructose 1,6-biphosphate is converted into true triose sugar by the enzyme called fructose biphosphate aldolase.
These triose sugar are glyceraldehyde 6-phosphate GA3P and dihydroxyacetone phosphate DHAP. And then DHAP is converted into second molecules of GA3P. Now, both molecules of GA3P can enter the second stage of glycolysis, which is energy payout stage.
In this reaction, GA3P is converted into 1,3-biphosphoglycerate by glyceraldehyde phosphate dehydrogenase. It also produces a molecule of NADH from reduction of NAD+. Then, 1,3-BPG is converted into 3-phosphoglycerate by phosphoglycerate kinase and generates a molecule of ATP.
Then, 3-PG is converted into 2-PG by phosphoglycerate mutase. Next, 2-PG is converted into phosphoenol pyruvate by enolase. At the end, phosphoenol pyruvate is converted into pyruvate by pyruvate kinase, which yields the second molecule of ATP.
Oh, now I fully understand about the process. Thank you guys.
Oh guys, my friend Nani are asking us to have dinner with her later because she is fasting. Do you guys want to join?
Yes.
Sure.
Okay.
Oh my god, my stomach is growling, guys. It's still not Maghrib yet.
Not yet, Nani. Nani, but you were all hyped up this morning. Why do you look like a dead fish now?
Maybe her body is fully undergoing gluconeogenesis.
Gluconeogenesis? What is that? Can you explain more?
Sure, Ifti. Gluconeogenesis is a process of synthesizing glucose from non-carbohydrate precursor. It occurs after 8 hours of fasting when liver glycogen stores start to consume and an alternative of glucose is required. This process occurs in the liver and the cortex of the kidney.
Gluconeogenesis has close relationship with glycolysis. Glycolysis is a breakdown of glucose, while gluconeogenesis is formation of glucose. But it's not the simply process, which is not a reversible step of glycolysis.
but it also has irreversible step in it.
So, it starts with pyruvate to phosphoenol pyruvate by several steps, and they require several enzymes such as pyruvate carboxylase, phosphoenol pyruvate carboxykinase, and malate dehydrogenase. Pyruvate carboxylase is found in mitochondria and convert pyruvate into oxaloacetate.
Oh, I know. It's because oxaloacetate can't pass through the mitochondrial membrane, so it must be first converted into malate by malate dehydrogenase. Then, the malate can pass through the mitochondrial membrane into the cytoplasm when it is converted back into oxaloacetate by another malate dehydrogenase. Lastly, phosphoenol pyruvate carboxykinase will convert oxaloacetate into PEP. Then the next several steps are the same as glycolysis, only it is in reverse.
This step differs from glycolysis is the conversion of fructose 1,6-biphosphate to fructose 6-phosphate by the enzyme fructose 1,6-phosphatase. The conversion of fructose 6-phosphate to glucose 6-phosphate uses the same enzyme as glycolysis, which is phosphoglucoisomerase.
The last step is glucose 6-phosphate is converted to glucose by enzyme glucose 6-phosphatase.
Oh, now I see. Thank you, guys.
Hi Nani, what are you guys talking about?
Nothing serious, we just discussed about gluconeogenesis pathway.
But same as us, we are talking about glycolysis pathway just now.
Glycolysis and gluconeogenesis? How can they be related? I cannot find the similarity.
Both pathways share many of the enzymes in producing and breaking down glucose for us to do activities. But glycolysis and gluconeogenesis have many differences.
Yes, it's true. Glycolysis occurs in the cytoplasm of all cells.
Yes, in gluconeogenesis, it occurs only in mitochondria and cytoplasm.
And also, glycolysis is a catabolic process and an exergonic reaction.
And for the gluconeogenesis is anabolic pathway and endogonic reaction.
Yeah, for glycolysis, the raw material is glucose.
Yes, Dina. For gluconeogenesis, the raw material are amino acids like alanine and glycerol.
For glycolysis occurs through 10 reactions.
And for gluconeogenesis, 2 irreversible reactions in the glycolytic pathway are bypassed through 4 distinct enzymatic reactions.
Oh guys, it's Maghrib already. Let's dinner together.
Let's go!
To conclude our video, we can see that the scenarios we discussed, which include playing badminton and fasting, represent the two metabolic states our bodies switch between every day. These situations show the constant shift between using energy and preserving it. First, we covered glycolysis. This is the pathway that breaks down glucose to produce ATP, providing the energy needed for muscles during physical activity. Second, we analyze gluconeogenesis. This is the process of synthesizing glucose from non-carbohydrate sources like lactate and amino acid. This is what allows the body to maintain blood sugar levels during a fast, ensuring that the brain and other vital organs have a constant supply of fuel. The most important concept to understand is that these two pathways are shared and regulated. In simple terms, this means that when one pathway is highly active, the other is inhibited. The body uses specific enzymes to control this switch. For example, when energy levels are high, the body slows down glycolysis and favors storage. This strict regulation is essential for homeostasis. It prevents a futile cycle where the body would waste energy by building and breaking sugar at the same time. In summary, glycolysis and gluconeogenesis are two sides of the same metabolic system. They work together to ensure we have energy when we move and stability when we rest. Understanding this balance is crucial to understanding how the human body adapts to various demands. Thank you for your time, and we hope this video has been helpful.